this problem, we're trying to figure out the gravitational force that a ring has over a particle that's standing directly in front of it, perpendicular to the ring's center. So the facts are, capital M represents the mass of the ring, lowercase m the mass of the particle, capital R the radius of the ring, X represents the distance of the particle from the center of the ring, C represents the distance of the particle to any point of the circumference of the ring. First, we need to find out what C squared is. Does this look familiar? That's Pythagorean theorem. So we can say that the distance between the particle and the circumference of the ring at any point on the circumference on the ring is C equals the square root of R squared plus X squared. If we were to open up the ring and lay it flat, we can say that its length is equal to 2 pi r. 2 pi r, which is the circumference of a circle. To find the gravitational force that the ring has over the particle, we must add up the individual contributions that a single section of the ring contributes to the force. So we have a single section of the mass, of the total mass, dm, over a small section of the length of the total length, that's dl. A small section of the mass divided by a small section of the length is proportional to the overall mass of the ring and the overall length of the ring. We already established that the length of the ring can be calculated with the formula 2 pi r, the circumference of the ring. And we solve for dm, which will end up with mass over 2 pi r dl. At this point, we're done gathering information. We calculated C and we calculated dm. Now we're going to be using G. G is a constant, and this is the value, 6.673 times 10 to the negative 11 newtons, meter squares per kilogram squares. We're going to need that information to calculate the gravitational potential energy, which is this formula, which is negative G, the mass of the particle, times the mass of the ring, divided by C. We know what C is, we know what M is, and we substitute those values in our formula. Once we make those substitutions, we integrate from 0 to 2 pi r, which is the length of the ring or the circumference of the ring. Now we find that all of these values are constant except dl. After we integrate, we end up with negative g times the mass of the particle times the mass of the ring divided by c, which is the distance from the particle to the circumference of the ring, times 2 pi r times l. And that's evaluated from 0 to 2 pi r. When we evaluate, we find that 2 pi r and 2 pi r cancel each other. And this leaves us with our final product, which is this gravitational potential energy. Now that we have the gravitational potential energy formula, we can find the force. The force is given by the downslope of the gravitational potential energy with respect to x. Now we just fill in the blanks for the formula, and what I did is I turned the denominator into a negative exponent. Now I use the power and the chain rules to differentiate. Let's not forget that r squared is a constant. And we end up with the force that the ring generates over particle.